Next, using integrals of set 3, we can integrate integrals of the form root of quadratic and linear times root of quadratic. For example, so we have to integrate root of x square plus x plus 1 dx. Root of x square plus x plus 1 dx. So what we do is we first complete the squares for this. So this becomes integration of root of x plus half whole square plus 3 by 4, that is root 3 by 2 whole square dx. That is equal to integration of root of x plus half whole square plus root 3 by 2 whole square is root of x square plus a square. So this is of the form root of x square plus a square dx. So once you see this form, you have a direct formula x by 2, that is x plus half by 2 times root of x square plus a square. That is, this is exactly same as x square plus x plus 1. So x by 2 root of a x square plus a square plus a square by 2. A square is 3 by 4 by 2. So what is the normal integration of 1 by root of x square plus a square? Log of x plus root of x square plus a square. So plus a square by 2 log mod x plus half x plus root of x square plus a square, that is root of x square plus x plus 1 plus c. So x by 2 root of x square plus x plus 1 plus a square by 2 log of this plus c. So this is the integration of root of quadratic. So whenever you have root of another quadratic also, the process is same. So you complete the squares first. So it will get converted into either x square plus a square or x square minus a square or a square minus x square. So depending on the form which you get after completion of squares, you apply the formula. So that will give you the final answer. So next, let us go for a linear root quadratic type. For example, if you want to integrate x minus 1, that is a linear, times root of quadratic. Here also the process same. So you need to express the linear term that you have as some alpha times d by dx of the quadratic plus some beta. So first what I do is, first I'll adjust the linear term. So to adjust the linear term, what you just need to do is, you write the differentiation of the quadratic. The differentiation of quadratic is 1 minus 2x, right? 1 minus 2x. Now adjust the x term first. So the coefficient of x is 1 here. The coefficient of x is minus 2. So I'll multiply it with minus 1 by 2. So if I multiply it with minus 1 by 2, you get x here. But you have an extra minus half here. But I need a minus 1 here. So you need an extra minus half into root of 1 plus x minus x square dx. So I have expressed the linear term as some alpha times d by dx of denominator, d by dx of quadratic plus some other constant. So now I'll separate these two. That is equal to minus half times integration of 1 minus 2x times root of 1 plus x minus x square dx minus a half times integration of root of 1 plus x minus x square dx. So 1 minus 2x is the differentiation of this. So in the first integral, if you assume 1 plus x minus x square is equal to t, 1 minus 2x dx will become dt. So this integration is minus half integration of root t dt. That is minus half times t power 3 by 2 by 3 by 2. So this 2 and 2 gets cancelled. That is equal to minus 1 by 3 times 1 plus x minus x square whole power 3 by 2. So this integration has been done. Next, let us go for this integration. Again, this is same as root of quadratic. So you need to complete the squares and then apply the formula. So let us try to complete the squares. So 1 plus x minus x square is nothing but minus of x square minus x minus 1. That is minus of x minus half whole square. That is x square minus x. Plus 1/4 is there. So you need a minus 1/4. Along with minus 1 you get minus 5/4. So that is equal to 5/4 minus of x minus half whole square. So this is 5/4 minus of x minus half whole square. So this integration becomes integration of root 5/2 whole square minus x minus half whole square. So root of a square minus x square. So answer is x by 2, that is x minus half by 2 into root of a square minus x square. This is same as 1 plus x minus x square. Coefficient of the constant term is positive. So plus a square by 2. A square is 5/4 by 2. A square minus x square integration is sine inverse of x minus half by root 5/2 plus. So this integration is this. You just need to put along with minus half. So this is how you integrate linear times root of quadratic. So whatever linear is there, whatever quadratic is there, you can always use this process. Linear has to be expressed as some alpha times d by dx of quadratic plus some beta. So I hope you have understood how to use set 1, set 2 and set 3. The different problems that you can solve using set 1, set 2 and set 3. So next time, whenever you get problems, you need to see which model the problem is and try to follow the corresponding process.